So today we'll look at derivatives of inverse functions, and we are doing this because it helps connect logarithms and exponentials. So we've already studied logarithms, and we'll see how we can easily see a connection to the derivatives of exponentials. So let's start with a review of inverses. X squared, and the inverse is radical x. We wouldn't say that this is the inverse of just x squared by itself, because if we reflected the parabola, then it would not be a function. So we only want the top half of the parabola, and we can do that by saying that the parabola, we will only use the right side of the parabola where x is positive, and we'll see that in the graph. So we have coordinates for f, and remember that we just have to switch the x and y values, and these will be the coordinates for the inverse of f. Let's look at the derivative of f and also the derivative of the inverse, and we remember that radical x is x to the 1/2, so we'll have the derivative of this, the derivative being this. Alright, then we're going to graph each function, the parabola and the radical. So here's the graph. And now let's look for a relationship between the slopes of the parabola and the slopes of the square root. So if we looked at the slope of this line, the point of tangency is 3, 9. So at 3, 9, we have a slope of 6, because the slope is 2 times the x value. Slope is 6. Let's look over here at this tangent line. Let's find the slope of this tangent line at 9. So here at 9, 3, the slope is 1 over 2 times the square root of 9. X is 9, put a 9 there, we get 3, so the slope is 1/6. And we can see a relationship between the slopes. So 3, 9 has a slope of 6. 9, 3 has a slope of 1 over 6. Let's just see if that continues. And here we have a tangent line at 2, 4. And it does have a slope of 2 times 2. 2 times 2 is 4. The slope is 4. And let's look at this tangent line. Its point of tangency is 4, 2. And it has a slope of, put the 4 in here, and that'll give us 2 times 2, or 1/4. So we see that if we know the slope of a function, then the reciprocal of that is going to be the slope of the inverse function. But there's one, we don't want to jump ahead too much, and let's look at an error. So what if I say that the inverse function's derivative is equal to 1 over the derivative of the function? And that looks like it's agreeing with what we see here. Here's the inverse function. Its derivative is the reciprocal of the derivative of the function. But let's put some numbers in there and look at, then would we say, if we want to look at, we want to find the derivative of the inverse at 4. So the derivative of the inverse at 4 equals 1 over the derivative at 4 of the function. And So, what's the error here? When we look up here, we have this slope is the slope of this line is 1/4, and we know that the slope of this line is 4. We know they're related, but I want to find the derivative of the inverse at 4, but it's related to the derivative of the function at 2. So here is the problem with this statement. We don't use a 4 here. Here's the formula. The formula is written like this, and it's easy to make the mistake of just putting the same number there. It's possible that that's the same number. Usually it's not. At this point, we would have the same number for both the function and its inverse. So here is how we have to understand this. This is an x value of f. This is an x value of the inverse of f. Or we could say it's a y value of f. We would substitute x values into f, but this is a y value of f that we substitute into the inverse function. And we'll see more examples of that. So the correct statement here would be the derivative of the inverse at 4 is 1 over the derivative of the function at 2. So we have to pay attention to the corresponding points. If I put a 2 as an x value into f, its y value is 4, so 4 is what will go into the inverse function. And let's see how that shows up in the graph. 4 on the inverse is corresponds to 2 on the function. Oh, this should be a negative 1/2. Okay, so a lot of words here, but we'll just do a couple of these to help understand the relationship between the derivatives. Okay, so let's start with graphing this function. We know that its x-intercepts are 0 and -1, 0, -1. So this says only graph it for values to the right of -1/2, and that's because we are going to reflect it. If we have a whole parabola and we reflect it, then its inverse won't be a function. So let's look at some other points. Put a 1 in there and we'll get a 2. Put a 2, we'll get a 6. And going like that. The other half of the parabola is over there. We're not going to look at that. Okay. Then we're going to draw the tangent line at x = 1. Okay, so to draw the inverse function, we have 1, 2, so we're just going to go 2, 1. And we had 2, 6, and 1, 2, 3, 4, 5, 6. We're going to go 6, 2. We had, we have 0, 0, so that will also be on the graph, and then we just have something happening over there. All right, so there's the inverse function. We have f of x and the inverse of f. Let's look at the tangent line here corresponding or symmetric to that tangent line. And we want to find the slopes of the tangent line. So f prime is 2x plus 1, and if we want to find the derivative of the inverse at 2, then we need to find 1 over the derivative of the function at its corresponding x value. So if the x value of the inverse is 2, we need to find out the x value when we have a y value of 2. So we need this to be a 1. F prime, so it'll be 2 times 1 plus 1, and we get 1/3. All right, and we didn't have to find the inverse function, and we didn't have to find the derivative of. We didn't have to find what this equals, and then since we don't know that, we couldn't find the inverse, the derivative of the inverse. Instead, we find the value of the derivative by using the reciprocal of the derivative of the function. Alright, so repeat the same question for this function to the right of 0, make a tangent line at 2, and then also draw the inverse function and find the corresponding tangent line, the tangent line that's symmetric to this point. Pause the video and try that. Here we have reflected parabola shifted up 1. And we're only going to graph the right side. We can go over 2, down 4, 1, 2, 3, 4. Alright, there's f. Then we just have to reflect, we have to switch the coordinates. So if we have a point at 0, 1, now we'll have a point at 1, 0. So the inverse will be in red. There's a point on the inverse. Here we have 1, 0. So we're going to switch that and we'll have 0, 1. And then we have 2, negative 3. So we'll go negative 3, 2. So these points in red are the inverse function. Let's look at the tangent line at 2. At x equals 2 on f, we have a tangent line there, and its corresponding tangent line on the inverse would be right there. And if we find the derivative of f, negative 2x, we want the derivative of the inverse at negative 3. 1 over f prime of 2. So we want to make sure that we have this x value being the slope, being the x value, we're finding the slope of the tangent line, and then we have to use that. 2 would be a, or we say negative 3 is going to be the y value of 2. So we go over 2, down 3, so negative 3 is how far we would go for the point of tangency on the inverse function. So make sure that if we're finding a slope of an inverse, this is the y value of f at that x value. And put a 2 in there, we get negative 1/4. And so this is more common question. It just says find the derivative of an inverse. So let's look at, we don't have to draw a graph. We just have to remember that if 9 is going to be here, we want the derivative of the inverse at 9. That means 9 is a y value of f. 9 is an x value of the inverse. That means it's a y value of f. So the derivative of the inverse at 9 is 1 over the derivative of the function at some x value. So we say that 9 is the y value of f. And we get 2. 2 is the x value for that y value. So put the 2 in there. F prime is 3x squared. So we'll have 1 over 3x squared, and we get 1 over 12. Pause the video and try that one. Well, we want to find the derivative of the inverse at negative 3. We know that's going to be 1 over the derivative of the function at the x value for this y value. So we say that this is going to be negative 3, and that's equal to x cubed plus x minus 1. Now, usually when these problems are given, these types of problems, this can be solved with just guessing some integer value here. So a lot of times on previous AP tests, that was easy to solve. If that wasn't true and we had to add this over here, then we have to go through, if you didn't have a calculator, then you have to start looking at possible rational zeros and synthetic division. So we'll just make these easy enough to check mentally. So normally we would move the 3 over and factor, but here let's just guess and check. We're going to add a 1, and we just think what number could we put here and here to make negative 2, and it turns out it's negative 1. Negative 1 cubed is negative 1, put a negative 1 there, and we'll get negative 2. So the x value for that y value, this x value is going to go here, and we need f prime, which is going to be 3x squared plus 1. So here we have 3x squared plus 1, and we put a 1 in there. So that'll be 3 plus 1 and 4. And we'll stop there.